Yeah. Hi, welcome to lesson 12 of our geography series. In previous class, we have learned about composition of atmosphere, constituents of the atmosphere, um, how Earth receives heat, what are the factors that are responsible for the amount of heat received by different parts of the Earth, and how the temperature is distributed on the entire Earth, and effects of the temperature like inversion of temperature, air stability and instability. And also we have learned about factors responsible for the distribution of temperature. Okay, what are the different factors responsible? That is altitude, and also you know latitudinal variations and all. And we have also learned about how heating and cooling of atmosphere happens. That is through conduction and convection. How heating and cooling happens in the atmosphere. Okay. And after temperature, the next important climatic factor would be pressure. Okay. But before going into pressures and pressure belts, we have to learn about different seasons that happen on the earth due to the amount of heat received. Okay. And while we are dealing with the amount of heat received, we have to learn about heat budget. Okay. And after learning heat budget and seasonal variations due to the amount of heat received, we will learn about isotherms. Okay. Yeah. Now, first we will look into heat budget. Okay. So, what is heat budget? The amount of insolation, that is incoming solar radiation. Incoming solar radiation is called as insolation. The amount of insolation and the amount of terrestrial radiation, that is the amount of heat that is radiated back into space by the earth, is called as terrestrial radiation. And if these two are balanced, we call it as a ideal heat budget. Okay. Yeah. So say let's say 100% of sun's rays are directed towards the earth. Okay. Towards the earth, 100% of sun's rays are directed. Out of this 100%, 35% are reflected. Even before entering our Earth's atmosphere, 35% of incoming solar radiation is, like reflected. And causes of this reflection are 29% by the clouds, 6% reflected directly into space itself due to, various amount of space debris, and 2%, sorry, it's 27, and 2% by Earth, reflected by Earth. Okay. 35% of incoming solar radiation is reflected back into space, and this reflection happens through clouds, uh, like by space debris and by the Earth itself. Okay, and by the Earth itself. So we can say that Earth only receives 65% of insolation. Okay, Earth receives only 65% of the insolation. Out of the 65%, 14% is absorbed by atmosphere. Okay, out of 65%, 14% of insolation is absorbed by the Earth's atmosphere, and remaining 51% is absorbed by Earth. Okay, so technically, we speaking, uh, technically speaking, uh, Earth should radiate back only 51% of terrestrial radiation. Okay, Earth should radiate back only 51% of the terrestrial radiation. Okay, so out of this like 15%, 51%, sorry, 17% is radiated directly by Earth. and remaining 34% of terrestrial radiation is absorbed by atmosphere. So in total, atmosphere absorbs 14% of insolation and 34% of uh, terrestrial radiation. So total 48%. Okay. Atmosphere absorbs 48% of radiation, and out of it 14% is from insolation and 34% is from what terrestrial radiation. Okay. Yes. So we have received 51% and Earth, we means Earth received 51% and Earth radiated back 51%. So there is a balance in the budget. Okay. Now there are two statements are very much important here. The first one is sun is important source of heat for Earth. Okay. And second is Earth is important source of heat for atmosphere. Okay. Sun is the important source of heat for Earth because Earth absorbs 51% of incoming solar radiation and it gets heated. Okay. And Earth is important source of heat for atmosphere. So if you observe clearly, atmosphere absorbs total 48% of radiation, and out of it 34% is of terrestrial radiation. So the radiation coming from the Earth is absorbed by the atmosphere and it is getting heated up. So major part of the heating of atmosphere is caused due to terrestrial radiation. So we will say that Earth is important source of heat for atmosphere. And moreover, in previous class, we have learned that the angle made by sun's rays gets decreased from equator towards the poles. So from 40 degrees north to 40 degrees south, there will be surplus of heat. That is, like this equatorial region tropicals combined, there will be surplus of heat, and beyond 40 degrees, that is from like 45 to 90 in northern hemisphere and 45 to 90 in southern hemisphere, there would be deficit of heat because of the angle making by sun's rays get decreased because the sun's rays fall slantly on higher latitudes due to shape of the earth, due to like shape and tilt of the earth. All right, and next, yeah, this surplus heat in tropical region is surplus heat in the tropical region travels to deficit regions due to formation of the gradient, and so the tropics do not get excessively heated, and polar regions, like they do not get frozen in a permanent condition due to disperse of heat from tropics to poles. Okay. Yeah. After this, seasonal variations. Yeah. Due to rotation of the earth, uh, oh, excuse me, due to rotation of the earth, we can see day and night. Okay. But due to revolution of the earth, we can see different seasons. Okay. That is the summer, spring, autumn, winter, etc. Okay. Due to revolution of the earth. Revolution. It happens around the sun. It is elliptical and clockwise. Okay. If this is sun, Earth rotates in an elliptical way, like in an elliptical way, and all in an east to west direction, that is clockwise, and it revolves around the sun. And also, please don't mind my diagrams. I'm really bad at drawing. Uh, and uh, Not only revolution, Earth rotates on its own axis also. While rotating on its own axis, it revolves around the sun by rotating by itself. It revolves around the sun. Due to this revolution, different parts of the Earth comes under the influence of the sun, and certain parts of the Earth goes out of focus of the sun. So the parts coming into the influence of the sun uh, experience summer, and the parts that are out of focus of the sun's rays experience winter. And this coming under influence of the sun, getting out of focus of the sun, it is due to shape of the earth. Okay, see, this is the shape of the earth. Earth is tilted, tilted. See, due to this tilt, if you observe here, this part is bulged part, and this is quite away. If sun's rays are here, they will be more focused towards the sun's rays, and this northern part experiences summer. This southern part is away from the sun and experience less sun's rays, and they experience winter. Okay, gradually due to revolution for this southern hemisphere comes into focus of the sun. That is, southern hemisphere would be it comes under the influence of the sun, and northern hemisphere would be, like out of the focus of the sun, somewhat like this. Okay, southern hemisphere would be coming under influence of the sun, and northern hemisphere is out of focus of the sun, and that means sun's rays, do not fall vertically on northern hemisphere. They cover much less area of northern hemisphere, and northern hemisphere experiences winter, and southern hemisphere experiences summer. Now we look into which time of the year this summer and winters takes place. Okay, if you start at March 21 or 22, what happens? Sun's rays fall vertically on equator, and we experience spring equinox. Okay, sun's rays fall vertically on equator, and we experience spring equinox. Okay, that means sun's rays make 90 degrees with the equator. Okay, sun's rays make 90 degrees with the equator, right? So that what happens? The equator receives more sunlight during this equinox period. And another effect of equinox is both northern hemisphere and southern hemisphere experiences equal amounts of day and night. Equal amounts of day and night. While sun's rays are falling vertically on equator, both northern hemisphere and southern hemisphere experiences equal amount of day and night. Why? Both while equator is receiving 90 degrees, the angle made by sun's rays on subsequent latitudes, subsequent higher latitudes, is same at northern hemisphere and southern hemisphere. So they experience equal amounts of day, because beyond equator, all the latitudes in northern hemisphere and southern hemisphere receive equal amount of sunlight. And also they experience same equal amount of night. Okay, for the same reason, as the Earth rotates, the sun slowly fades away, and other part of the Earth comes under the influence of the sun. So the previous part experiences equal amount of night. Okay, because of both northern hemisphere and southern hemisphere receives equal amount of sun's rays during equinox period. Okay, next, what happens? This is Arctic Circle and Antarctic Circle, Arctic and Antarctic. Yeah. Slowly from March, Earth is rotating in a clockwise direction and sun's rays are shifting northward. That means northern hemisphere is coming under the influence of the sun. So Earth is moving after the equinox, it is moving in a clockwise direction. And on June 21 or 20, I like 21st or 22nd, what happens? Sun's rays fall vertically on Tropic of Cancer while rotating from March to June. What happens? The sun's rays start shifting northward. That means northern hemisphere comes under the influence of the sun, and slowly the sun's rays starts shifting northwards, and they make larger angles with the higher latitudes. That is beyond equator. Beyond equator, sun's rays make a larger angle with the higher latitude. That is the 10 degree, 50 degree, and Tropic of Cancer. Okay, for example, let's say after March 21 or 22, sun's rays shifted northward. That means sun's rays are 90 degrees at 10-degree latitude. After some period in May, it is on 15-degree latitude. And in June, and on June 21 or 22, it is 90 degree on Tropic of Cancer. That is in the Tropic of Cancer is in the northern hemisphere. Okay. And at this time, when sun's rays are, like they are on Tropic of Cancer, entire northern hemisphere comes under influence of the sun, and more amount of northern hemisphere, receives more sunlight, and we say it is summer solstice because as the sun rays are moving up due to this. See, this moving up means it's not like sun is shifting northwards. Sun is it is at a it is stationary. It is at the exact same position. It is the earth that is revolving around the sun, and slowly what's happening due to this shape, uh, this northern hemisphere is coming under influence of the sun. So sun rays are more focused on northern hemisphere. So northern hemisphere experiences summer. Okay, from April onwards, we experience summer. And on June 21 or 22, it is peak summer in northern hemisphere. Why? Uh, the sun's rays fall vertically on Tropic of Cancer. And at the same time, you have to observe that southern hemisphere is out of focus of sun rays. So southern hemisphere experiences winter. Compared to northern hemisphere, southern hemisphere receives less amount of sun rays during summer solstice. Okay, so southern hemisphere like receive southern hemisphere experiences winter. And third phenomena is Arctic Circle comes under the influence of the sun, and Antarctic Circle goes out of focus of the sun. So during summer solstice, for 6 months of period, Arctic Circle experiences day. and Arctic Circle experiences day during summer solstice because northern hemisphere comes under the influence of the sun due to its geoid shape, bulging at the equator, right? This part comes under the influence of the sun. So Arctic Circle also receives high amount of sunlight, and for 6 months, that is from June to December, uh, Arctic Circle experiences day, and Antarctic Circle experiences total night from June to December, because Antarctic Circle completely goes out of focus of the sunset because southern hemisphere is out of focus of the sunlight. Okay, so we can say that due to rotation, uh, the parts of the Earth that are between Arctic Circle and Antarctic Circle experiences day and night. Due to rotation, the parts of the Earth between Arctic Circle and Antarctic Circle experiences day and night. But Arctic Circle and Antarctic Circle experiences day and night due to revolution of the Earth. Okay, due to this revolution only, Arctic Circle comes under the influence of the sun during summer solstice, and it experiences complete day. There is no night at all. Okay, because the circle, the polar region itself comes under the influence of the sun due to the tilt. Okay, so the tilt is maintained from June to December. Earth revolves with the tilt from June to December. Slowly, what happens while coming from June to December? See, if this is the initial position that is on the June, as we move from June to December, slowly what happens? This if this is northern hemisphere, my fish is northern hemisphere, it slowly goes out of focus while revolving, and my wrist is southern hemisphere, and southern hemisphere comes under the influence of the sun. It's not like Earth is not coming upside down; it's revolving, and due to its shape, that bulged shape, certain parts of the Earth comes under the influence of the sun. Okay, this is what happens during summer solstice. Day and night in Arctic Circle and Antarctic Circle are due to revolution, and remaining parts of the Earth, day and night is due to rotation. So again, Earth moves from east to west, away from summer period, and on September 21 or 22, we experience autumn equinox. Again, equinox. That means sun's rays fall vertically on equator. This indicates that sun's rays are slowly shifting southward. From Tropic of Cancer, they are shifting southward. And on September 21st, they are at 90 degrees with the equator, that is equinox. So during equinox period, southern hemisphere and northern hemisphere experiences equal amount of day and night again. So from September 21 to again, Earth is revolving east to west direction. And on December, what happens? Tropic of Capricorn receives high amount of sunlight because as Earth move from June to December, southern hemisphere comes under the influence of the sun. Southern hemisphere comes under the influence of the sun, and northern hemisphere goes out of focus of the sun. So on December 21, 22, northern hemisphere experiences winter, and southern hemisphere experiences summer. Okay, and again, what happens from December to March? Again, slowly sun rays start shifting towards north, and spring equinox, summer, autumn equinox, winter. So this is the whole year where different seasons happen due to the different amount of sunlight received by the different parts of the earth. Okay, during winter solstice, what happens? Arctic Circle experiences complete night, and Antarctic Circle experiences complete day. So these are the seasonal variations. Uh, like, please do remember this cycle. Okay, it is very much important while we are learning about world climate. Okay, right? At what periods of time like sun's rays fall at 90 degrees on different parts of the earth, or at what periods of time sun's rays make different angles with different latitudes of the earth. You have to remember it. So if you remember these logics, it will be very much easier to study world climate. Yeah. So we are done with seasonal variations. Now we will go into isotherms. Right. Isotherms are nothing but they are imaginary lines joining places of same temperature. Okay. See, if this is Earth, different parts of the Earth have different temperatures, right? So if you draw certain lines joining all the you know uh, all the places having equal amounts of temperature, if you draw imaginary line, like let's say 10 degree centigrade line, so it might be like this. Okay, because we are joining places of equal temperatures, right? And this is a northern hemisphere. And if you take southern hemisphere, what happens? The isotherm would be somewhat parallel to latitudes. Why? Because of the predominance of the oceans. Due to large amount of ocean in the southern hemisphere, what happens? There will be more places with equal amounts of temperature. There will be no differential rate of heating. Differential rate of heating is more pronounced in northern hemisphere due to predominance of the land. As there is more land mass, and there is a difference of heating between lands and the oceans. Lands heat quickly and also loses heat quickly compared to oceans. So why we have discussed in first class of climatology, please do visit that class. We have discussed all the logics in first two classes, and there will be more concepts and logics in coming classes. You have to like go back to previous class if you have any doubts regarding these small logics, like why land gets heat quickly, why oceans get why oceans take time to lose heat, uh, why dry air is like hotter, and why moist air take time to heat up and also take time to lose heat quickly. Why air stability or instability occurs during dry air and moist air conditions. We have discussed in the previous class. Please do visit them. Okay. Yeah, where were we? Here. Due to predominance of the land in northern hemisphere, what happens? There will be differential rate of heating. Ocean gets heated up at a different rate and loses heat at a different rate. Land masses heats up at a different rate and loses heat at a different rate. Okay. So that's why what happens? These isotherms shift gradually. Okay. Yeah. And in southern hemisphere, these isotherms are more or less parallel to latitudes because there is entire southern hemisphere, not entire, 70 to 80% of the southern hemisphere consists of oceans only, and entire ocean has almost uniform temperature. So if you join all the points in the southern hemisphere, they are almost parallel. And why these isotherms? See, climatologists simulate these isotherms to know about temperature gradients. Okay. See, let's say in certain period of time, Rocky Mountains are on one isotherm, like let's say minus 20 degree isotherm, and after certain period of time, they are at minus 10 degree isotherm. There is an anomaly here. There is a difference here. Why this difference happens? So, uh, uh, scientists generate these isotherms and learn about the change in the climatic conditions or weather conditions happen in that certain places, and they take precautions accordingly. Okay, that's why climatologists simulate isotherms. Okay, so how to in exam point of view, how to learn these isotherms? Okay. See, in 2024 prelims, there is a question regarding isotherms. So, how does isotherm shift in different hemispheres in different seasons? Okay. In winter, how do they shift? In summer, how do they shift in northern hemisphere? Similarly, how do they shift in winter in southern hemisphere and in summer in southern hemisphere? We will look into it. Let's take northern hemisphere. 0, 30, 50 latitudes. It is a landmass and it is ocean. Let's take summer. Okay. Summer means July or June. I'm talking about entire northern hemisphere, not India. Okay. If you take entire northern hemisphere, the summer is most pronounced in June, July. Right. Yeah. So in summer, uh, like what is this? As we move from lower latitudes to higher latitudes, temperature reduces. Let's say it is 25 here, it would be 20 and it would be 15. Okay. Similarly, other side of the ocean, it would be 25 because oceans have similar temperature because they get heated up at similar rates. And here it would be 20. Here it is 15. And on land masses get heated up quickly. So they have more temperature compared to oceans. Let's say it is 30 here. And as we move from lower latitude to higher latitude, temperature reduces. So it is 25 here and 20 here. So how the question would be, what is the direction of the isotherm in northern hemisphere during summer conditions if we draw from sea to continent? So if we have to join places of equal temperature, so 25 to 25, right? So you drew it from sea to land. How does the isotherm is shifting? It is shifting northward. And similarly, if we draw isotherm from continent to ocean in summer in northern hemisphere, the isotherm would shift southward. Okay. Third, see how this isotherm is shifting. It is not linear. It is it is making a curved path because of predominance of the land. It is in northern hemisphere. So okay, let's take southern hemisphere now. And you draw similarly for winter in northern hemisphere. I drew it for summer. You draw it for winter. Okay. So in winter also, oceans are more land is more colder than oceans. And if we move from equator to poles, temperature reduces. So draw it accordingly and write down the statements. Okay. So if you take southern hemisphere. Yeah. So equator 30, 50. Similarly, we take a landmass, ocean. It is winter in southern hemisphere. So from equator to poles, temperature reduces. Let's say it is 25 and 20, 15. Similarly, oceans 25, 20, 15. Okay. And on land would be much cooler compared to what oceans. So 20, 15, 10. The statement would be like this: if you draw isotherms in southern hemisphere during winter from sea to land, how does the isotherm shift? So from sea to land, it is shifting northward or equatorward. See, from 30 to 0. It is shifting equatorward or northward. Okay? And write down the statements, okay? Don't get confused. Write down the statements and draw the diagrams. And in southern hemisphere, during winter conditions, if you draw isotherms from land to sea, okay, so from continent to ocean, how does the isotherm shift? It shifts southward or poleward, okay, towards the pole. See, towards the pole or southward. And in summers, if you draw it from sea to land, it shifts northward or poleward. And from land to sea, it shifts southward or equatorward. Right? In winter southern hemisphere, land to sea, pole. In summer northern hemisphere, land to sea, equatorward. In winter southern hemisphere, sea to land, equatorward or northward. In summer northern hemisphere, if you draw it from oceans to land, it is poleward. And draw accordingly for summer in southern hemisphere and winter in northern hemispheres. So this is it for isotherms. Right. In examination point of view, only isotherms are important like these statement kind of questions. And I have also said why scientists or climatologists simulate these isotherms. Okay. And yeah, uh, regarding this isotherms, there is a another concept called anomaly. So, if you take an isotherm, like let's say 10 degrees centigrade isotherm, the places located on this isotherm have similar temperatures. Okay, but sometimes uh, this condition is, this condition is not satisfied sometimes because on same isotherm, there will be places that are not in sync with the isotherm. If this is 10 degree centigrade isotherm, there will be high altitude where the temperature would be 5 degrees. It is called as anomaly. Okay? Iso anomaly. On the same isotherm, there are places which have different temperatures or which have temperatures not similar to that isotherm. It is called as iso anomaly. Yeah, that's all for today, guys. And in next class, we will learn about pressures, pressure belts, atmospheric circulation, and factors responsible for directions of the wind and all. Very important topic regarding world climate. And please do visit previous classes of climatology before we start pressures. So in next class, there would be regarding pressure. And yeah, that's all. Thank you. And yeah, please do let me know in the comments if you have any queries or doubts. Okay.